So now I'm going to record this and let's start. So we have 38, which is I'm 39th person. So I hope you have gone through your syllabus. If you have any question related to syllabus, I already posted the recording related to syllabus. So if you have any question, you can ask. Otherwise, I'm going on module 1. Yeah, Christina, I know you were in my online face-to-face class in fall 2019. You attended my BADM 503 in fall 2019, if I remember correctly. And we don't have any option that, you know, all the face-to-face students has to be transferred to online because face-to-face program is no more. So yeah, so you were, yeah, so we don't have any face-to-face MBA class now. So yeah, so final will be mixed of MCQ and fill in the blanks. That's correct. That's correct. So it will be a mix of both. You will have data set to do analysis on Minitab and you'd have to come out with the answer. So it is going to be both of the mixed of MCQ and fill in the blanks. So I'm going to, if there's no question about syllabus, this is actually, you know, this was earlier, but you know, since we have a lot of you students and you know, some of them are not able to do by Wednesday, therefore I relaxed this condition. You know, the due date is, everything has due date. So before due date, everything is fine. So nothing is going to harm you. So for example, this is week 1. The due date is February 15, February 15, February 15. 11:59 p.m. So but before that, if you do, that's fine. So Christina, you know, it's always good to make a critical, you know, observation, critical alignment of the applications and, you know, use of tools and techniques in your professional world. So, you know, even this is, I'm just, you know, not making it hard and fast, not making it mandatory to have, you know, two people reply and 2 post reply. Is there a password for connect tool? So, you know, since, you know, we need only book for your reference point, Carla. So, you know, let me show you. So for example, this is this option. Under this, you know, a smart book is available. You know, I can only get the access of a smart book through this. And this is the option, or you have vital source book. You know, you will have only one access. So this is a vital source book, which is aligned with the book. So you need only this connect. We are not using connect part. So you don't need, you know, but you know, you can use for 1 week or 2 weeks. They have complimentary, you know, access of the things for a week or 2, but you only need a book. So you can do that. But otherwise you have to purchase, or, you know, we don't have a password for that. So I linked all the options so that you can start using books and material. So here you have a smart book, vital book, whatever you know, I think you will have the access of vital source book because I think you paid inclusive fee, which is $47 something. So that will have, you know, vital source, I believe. Okay, now if no question, I'm going over material. So you have already studied probability in the last class, which is BADM 503. And I assume those who are directly entering into the 520, they have the basic understanding of probability and what is a probability. So this is chapter 5, which is conditional probability and Bayes theorem. So we are going to talk about conditional probability. I will not take more than 30 minutes because this is not difficult chapter, and you have to do with, many calculation by Excel or by, calculator. So we are not using Minitab because first week always there is a problem in Minitab. So I don't want to put something that needs a Minitab. So therefore we put this chapter. So you can be familiar, you can have the access of Minitab and you can start it. So what is a sample space? These are the technical terms. All possible outcomes is, so set of all possible outcome in the sample space of experiment is called this. So what is the, for example, this is, if you have a die and you are rolling a die, what would be the sample space? Sample space would be 6, set of 1, 2, 3, 4, 5, 6. So in first case, the sample space is 6. What about if you are rolling 2 die together? What could be the possible things? The sample space would be combination of 2 dice. So combination, how many combinations are possible? These are the possible combination. 1, 2, 3, you can see in the matrix, sorry, these are the possible, these are 36. So the sample space would be 36. So all possible outcome in the experiment is sample space. So the sample space to describe a random chosen student GPA would be all such, and this is GPA is 4. So just let it be, make it very simple. Probability is between 0 and 1. We all already know this, and it can be 0, it can be 1. 1 means 100%, 0 means 0% or 0, no chance of event to occur. 100% means 100% chance to occur the event, and it can be in between any number, in decimal from 0 to 1. So this is the range of the probability, and probability is always denoted by P and bracket or parenthesis, probability of that event. So probability of A is this. Look into how do we start with, getting the numbers from real experiments or from real, professional world. For example, a restaurant or any store. At the end of the day, they get to know that, out of 1,000 transaction they had in their register, out of 1,000 transaction, they got to know that 320 transactions were done using credit card, 150 transactions were done using debit card, 350 paid through cash, and 180 paid through checks. And so for the the payment percentage is 13 to 15, 35, 18%, and together it's 100%. And in terms of probability, this 32% is noted or denoted by 0.32. Debit card is, probability of debit card is 15%, which is 0.15. And total sum of all the events should not exceed more than 1 or 100%. So sum of all the events should be not more than. So there are 3 kinds of probability. What is the probability in simple, definition? Chance of an event to occur, which is a probability. So basically I normally say the probability is nothing but a chance to occur for any event. That is what is probability. There are 3 types of probability: classical, empirical, and subjective. And empirical, like we just took the example from credit card, debit card, cash, and check. These are the 4 options. Under 4 options you can get the data. Based on data, you can do the empirical. Classical, known as prior, by the nature of the experiment. So you know the nature of the experiment and you know what are the chances. For example, rolling a die, there are, there is a chance of getting 4 when you roll a die is 1 divided by 6. That is almost 16 point or 0.1667. When you when you roll a die, I request, kindly just mute your microphones because so please. So when you toss a coin, there's a chance that 50% chance to have head, 50% chance to have a tail. So we know this, when you when you have a playing cards or playing deck of a card, what is the chance of getting red card out of that? So you have 50%, 26 cards are red, 26 cards are black, so 26 by 52, which is 50%. What is the chance of getting a king? There are 4 kings, and so 4 divided by 52. What is the chance of getting red king? There are 2 red kings, so accordingly that is kind of classical probability. And there's a subjective probability based on the judgment, opinion, and informed opinion. So for example, there is a 60% chance that Toronto will bid for the 2024 Winter Olympics. There is a chance that 2028 Olympic will be scheduled in Spokane. I mean, I'm just giving an example. So who can give this? An expert. For example, I'm a expert of, decision science and data analytics, and some companies are approaching to me and they ask me to, share the CV of, or you want to recommend some student for internship and those who can be helpful in data analytics. And I know when I teach my online, the classes, and I recommend, okay, this student can be a real resource because I know, because I taught a couple of classes and I know the performance, I know the student ability to handle the situations. Similarly, like, the coach, experts in the field like Warren Buffett, who knows the subjective, who knows where to invest because he has the knowledge about that, so probably if there is any company is going to sell, he knows what is the chance of, turning this company into profitable company. So, these are the 3 kind of probability: empirical, classical. We in real business world, we are dealing only, I mean, this is the most important thing, that we deal with the numbers. And that is what we are going to do in with this our homework with Titanic data. You can have real data based on different aspects that you deal with. So I'm not, just going over here. Law of large numbers. When you have, when you toss a coin, when you toss 10 times, you can see this is when you toss it 200 times, the probability becomes equal. Means here you can see it is coming 50-50%. When you do any experiment for large number of time, that means equal probability of all the events will be there. So flip a coin 50 times, we would expect the proportion head would be near 50% or 0.50. A small finite sample, any ratio can be obtained. So a large N may be needed to get close to. So this is a very simple, if you do any experiment for large number of times, the probability of all the events will be equal. Classical approach. So I just already spoke about classical approach. This is classical approach. What is the probability of getting 7 when you roll 2 die? So getting 7, when you roll 2 dice, these are the possible 7. 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6. How many of them? 1, 2, 3, 4, 5, 6. 6 divided by 36. How many? What is the probability? 0.1667. Now I ask you, what is the probability of getting 5 in this when you roll die? Look into the cases where you can get 5. So 2 plus 3, 5. 3 plus 2, 5. 4 and 1, 5. 1 and 4, 5. Do you see any other option where you are going to get 5 in this when you roll 2 die? So you don't get. So what is the probability here? I don't see any other places where you are going to get 5 together. So only these are the 1, 2, 3, 4 combination. 11%, 4 divided by 36. Yeah, that's correct. 0.11. We have to always put the numbers in 0.11, or we can't say 11%. So good. Both are correct. Thank you. So a subjective probability, what is the probability that new truck product program will show a return of investment of at least 10%? So I said the example of Warren Buffett or similar big people. They don't go with numbers. They just use their knowledge. They just use their experience, and they just use their own understanding to make decision. And they can think, and okay, if we put in this much money in this, we can get this much kind of return. So basically that is a subject. What is the probability that the price of Ford stock will rise by rise within the next 30 days? So these are all subjective probabilities. Now we are going to learn rules of probability, and this is very important to understand because visualization is very important to take care of this. So just a minute. So for example, this is a Venn diagram, and let's look. So if this is an event A, this is the total this is the entire area. If this event is happening in this area, the event A, so probability of event A plus probability of event complement of event A. So probability of event A plus event complement of event A equal to 1. So probability of complement of event A is equal to 1 minus probability of event A. So if you know any event probability, you can easily get the complement event probability by just subtracting that value from 1. Union of two events. So these are event A and event B. Look into this, and this is denoted by you can say up U letter, or this is in words, it is known as OR. Union of two events consists of outcomes in the sample space S that are combined either in event A or event B, or both, denoted by A or B, or this is known as A or B. And what is the formula of this? The formula is event A, probability of event A plus probability of event B minus probability of A and B. How? I'm going to demonstrate here. So since this is an intersection, look into this very simple understanding. This is one, this is the one. These are the two circles. When you combine these, let's say this area of this circle and this area of this circle, they are going to overlap each other. So this, when you do this, we need the, event A and B, event A or B. So this area is coming twice. Therefore, we have to subtract this one time. So the common area, which is overlapping, one from B, event B, one from event A, because it is coming from event A and event B. So we have to subtract this common area, and therefore this is called A and B, and it is denoted by A and B. So of all in the sample space as that are contained in both event A and B. So this is called joint probability or common probability. And now the formula is probability of A or B equal to probability of A plus probability of B. And this common area, since it is coming twice, we are subtracting one time, which is probability of A and B. If this is clear. Yeah, we are coming, in a tactical example, we are coming over there. So look into this. This is one of the example. For a standard deck, this is a deck, 4 out of 52s are queens, which is queen probability of queen. Red, there are 26 out of 52 are, this. For probability of queen or red, it's a 2 divided by 52. So which is overlapping. So what is the probability of queen or red equal to probability of queen, probability of red minus. Now look into the same example in practical world. Many stores, they have the option that you can pay partial from credit card, partial from debit card, partial from cash. Many of you have already done this in past that, you are going to use credit card. Also, you are using, let's say cash or some other payment method. So for example, paying by credit card, paying by cash, and there are some transactions in the, those are paid, partial with credit card, partial with cash. Is it? So look into, similar frame, Carla. What you can do, some of the students are having, this background, some of them have the common background of both the things. So look into this. So this is the probability, which is, queen, red, and which is common in both, this is the, so what is the probability of queen or red? Queen or red is equal to probability of queen, probability of red minus probability of queen and red, which is 4 divided by 52, 26 divided.
Sweet. Would you put on a new one for them, Dan?
I request everyone, please just mute your microphone. That will help, everyone to pay attention here, please. So PQ, PR minus PQ and R. So this is 53.5385, or in other words, 53.85%. So look into, these are other things which are mutually exclusive events. Let's say, these are the separate events. They are not overlapping, then this common area would be 0. Are you seeing, when they are mutually exclusive, then what is the probability P, A or B equal to probability A and probability B, because they are not overlapping. Now here, collectively exhaustive events. So these are only for theoretical understanding. Rest, we are not, using any assignment is not based on these things, but, it's important you can understand. So for example, any product that has warranty or no warranty, the total probability is A is probability of warranty and probability of, so this is event are collectively exhaustive if their union is the entire sample space. Two mutually exclusive collectively exhaustive events are binary events. So this is the example. This can be extended with, this, collectively exhaustive events continue, how many ways you are going to pay at a register in any store: cash, check, debit card, credit card, or there could be fifth option, which is called, what is called the electronic payment option, or, through some mobile device, there are some electronic application, payment application. So these are the options. Though, those are also gone through the credit check or debit card. So these are the four possible. This is the combination. This is the total sample space. Now, very important part is going to start, which is called conditional probability. What is the conditional probability? This is the conditional probability, and it is denoted by the vertical line, a small vertical line. So probability of event A, condition probability of event condition B. The vertical line as given, you can read as a given or as a condition. So what is the formula of this? Probability of A condition B equal to probability of A and B divided by probability B, where probability B is always greater than 0. Condition probability B is always greater than 0. So look into this. A and B, we understand what is probability of A and B. A and B is nothing but a common area between two events A and B. What is the probability? The total event, probability of event B. So this is denoted by this. Now here, consider the logic of formula. This is a common area, and this is the green. This is the event B. So this is how it is denoted. General law of multiplication. So what we have done, we are not doing this. We have just flipped this formula. How? So I want to know this probability of A and B. So this goes in the denominator. What is the condition is given, after given, this later part goes in the denominator. Is it making sense, Christina? So always remember, probability, this second part always goes into this. Now look into this. I would like to know this part. So what I can do, I can bring this part here, and that will become probability of A and B equal to probability of A condition B and probability of B. So exactly the same thing has been done in this probability of, yeah, please go ahead. Don't hesitate to ask, So probability of A and B equal to probability of A condition B and multiplied with probability. Looking for volume? Can you, any technical problem, any issue that you have? You can type in chat box. Okay, I'm moving forward. I think there's an issue related to volume because, so if restaurant accepts credit card, okay, then they take Visa. So yeah, this is a conditional probability that that credit card, given that a Visa powered or Visa enabled. So accept card given that Visa card. Yeah. Some resonance is coming back to me, I don't know. No problem. No problem. So just mute all your microphones. Look into this example here, right here. One of the population age between 16 to 25. at 21 and not in college, and this is the ratio that has been given or that has been obtained using empirical rules or government statistics, that they are able to see that there are 13.5% people are unemployed. They are also able to know using the data that high school dropouts are 29.5%, 0.05%. Based on school data, they also got to know unemployed and high school dropouts are 5.3%, 5.32%. So what is the conditional probability that a member of this population is unemployed given that person is high school dropout? So we would like to know that person is unemployed, you can get to know that he is not completed a high school. We can see. So look into this based on this. So so you can see what is the probability of unemployment, 13.5%, probability of dropout 2905.2905, probability of unemployed and dropout is 0.50532. So here, what is the probability of unemployed condition dropout? So based on the formula, probability of unemployment and dropout divided by probability of dropout. So you can see dropout is the denominator because it comes after condition. So we put the numbers and we are able to get the numbers, which is 18.31%. So those people are unemployed, unemployed and dropout means those who are dropout and unemployed, they are 18%. But, overall statistics, unemployed is only 13.5%. So what we can conclude here? We can conclude here that, this is greater than the third, those who are dropout, they are, their unemployment rate is 18.3%. However, only in unemployment rate is 13%, 13.5. Therefore, being a high school dropout is related to being unemployed. So we can get this conclusion based on this. How did you get 5 point? This is given us 5.32%. So, independent, when do we have the events are independent or dependent, though this is not in our assignment, but how you can get the independent event. So these are the few rules we have to think. If,
join the meeting.
Okay. So for example, so event A is dependent of event B if the conditional probability is the same as marginal probability, means probability of A condition B is equal to probability of A. Or other thing, if probability of P and B equal to probability of P and probability of B, then event are independent. So these are the rules which you can just see. However, we don't have any assignment based on this. So here, independent events, you can just, I'm just going to, Now another important thing for independent event, what is the chance that, why, for example, Amazon.com, how much time Amazon is not working, how much time that Amazon website is not working? Do you ever see in your life that whenever you want to buy anything on Amazon.com, you always find Amazon.com is working, or you find any technical glitch or any technical issue in that? Okay, you don't find, but I find sometimes. Why? And how do they do it? How they do it? For example, they have multiple independent servers which are working to run their show continuously 365 days, 24 hours, 7 days in a week. How they are doing? Look into this. Because, if they are having one server and entire operation is depend on one server, then, out of 365 days, there are chances that, it can lose the money. It can lose the website, and losing a half an hour business, how much costs them? Can you think critically how much cost them to lose the money? To not, let's say in simple words, if Amazon website is not working for 30 minutes, it's millions. Yes, it's a millions. How? A very simple calculation. You can figure it out using, your critical thinking. I'm not going to tell. However, therefore, what they do it here, let's say they have parallel servers, let's say I'm just going to take 4 of them, 3 and 4 servers together. And each server is like 95% reliable, 95% that out of 100 times, out of 365 days, 5% chances, 5% days means approximately 15 days. There is a chance that, oh no, not 15. Yeah, 100 days means 5 per 5, approximately 15 to 18 days, this server may not work. Similarly, this is also 95% reliable. This is also 95% reliable. Now, when you are using 4 things together, what is the chance that all will collapse at the same time? What is the probability the Amazon website or all servers will collapse? So it can be done very simply. You can do 0.05. This is the unavailability. 0.05 into 0.05 into 0.05 and multiply this. So I'm just going to use my simple calculator, and let me use this 0.05 into 0.05 into 0.05 into 0.05. So whatever I got, this is minus 101. So basically the answer is coming in, in minus, because I put minus at the end. So the availability would be 99, out of this. Let me do out of 365 days. How much time out of 365 days? How much it would be? 3. Oh, I did wrong. I have to put into, no. So one more time, I can use this number. Can I? Okay, into 365. So my dear friends, you can see if you use 4 servers together and 364.99771, it would be available. Mean 365 would be, days. Let me calculate this with 24 hours. So how much it would come? Oh, this is to, no. So into, so this will directly, how can I? Okay, multiplied by 24, because we have 24 hours, means 23.94 hours it is available. And 20, so let me do how much after that, so into 60 minutes are there. So out of 60 minutes, 56.715 minute. That means I will count almost 57 minutes. That means in a year, if Amazon is going to use 4 servers, there is a probability that 3 minutes probability they will not have Amazon website working. How much? Close to 3 minutes, approximately 3 minutes. If they are using 4 servers, they will have unavailability, there is a probability that 3 minutes they will not have the Amazon system or Amazon website will be working. If suppose they use 10 of them, this probability is also very, very negligible. In few seconds, I can't say zero. So I hope you understand the application of being independent. And therefore, when I go and I do, my work in India, what I do, India is very unpredictable in terms of infrastructure. I use 3 internet services to run my classes from India, 3 internet services, in order to be reliable, in order to be, keep taking class if one system, one service is not working, therefore. And so this is the application. There is one question in the, I think MCQ or fill in the blanks where you have to come out with this principle. You have to apply this principle. What is a contingency table? A very simple table. What is a contingency table? So based on contingency table, we are going to make a simple. So look into this. For example, I have 240 students in 4 sections of this course I'm teaching. Let me do this 4 section divided by this, for example, this is male, female, and this is, section 1, section 2, section 3, and 4th section. The grand total would be 240 here. Every section has 60 number. So this is, and now, so just, let's say I don't know exactly. I'm just taking, just my understanding. Here we have 22, 38, 33, 27. And what is the last? So I can say 30, 30. Can you say this is correct? Because, so this cross tabulation is a contingency table. So of all my classes, I'm teaching 200, so what is the number here? 30 plus 33, 63 plus 22, 65 and 85 plus 25, 85 plus 25, 90, 100, 110, if I am correct. 60, just a minute. This is 63 plus 83, 85, 90, yes, 110. So these are the males. How about females? I can simply go with, this would be 130. Now this my cross tabulation has been done. Now I would like to know the probability of different events in this. Let me see. What is the probability of section 2 and male? How I can see? The section 2 is this, male is this. What is the common area? 22. What is the divided part? 240. Similarly, if I see what is the probability of section 1 condition female, how I can see? So now I have to get the numbers, which is probability of 1 and female upon probability of female. Look into this. So what is the probability of 1 and female? 1 on female is this, 35 divided by 240. And this is entirely divided by it. What is the probability of female? So this is the female part, which is 130. Total females are 130 divided by what is the 240. So basically 240s are common. So this will, eliminate it. What you need to do, only 35 divided by 130. That would be your answer. Is it making sense? So this is empirical because gender may not be a yes. We don't know actually, Carla, how much, to be honest, I have not counted and I don't look into that. However, if I do this, in simple way to explain, therefore I took the example. You can do, for example, you can take a credit card, this from, paying check, paying cards, paying, you have all four category, and you can say, you can have different customer category, the member customer, non-member customer, or you can have different other things, and you can see, all different possible probability based on the numbers. So, and, basically, similarly, Amazon is going to do, Amazon is going to look into that. They have a customer, which is members customer, non-members customer, and they have the, the bucket, which is, classify the customer, those who are purchasing more than $2,000 per month. They have between 1,000 to 2,000. They have between 500 to 1,000, less than 500, and they can come up with this. And based on that, they can create the marketing campaign, and they can look, who are the most user, and they can create the marketing campaign. You can also look into different, different angle based on the data that you have in real life. So, okay. So this, oh, I'm sorry. I just erased this. I did not want to, because I wanted to do a lot of different things. Anyway, so where am I? So contingency table, I don't need to explain because I already given the, oh, it's gone now. Okay. So basically here you can see, this is the example. We can work with this. A small, here you can see these are the, consider the following cross tabulation or contingency table, where 67 are the students in top tier MBA programs. Here small, the salary gain is small, medium to high, large, low, medium to high. And here you can see, my dear friends, 5 of them are between this category, 10, and you can see the total numbers are 67 is right here. And now we are going to see how it is going to help. Now, if I ask based on that, what is the probability of a small gain? So what is the probability of a small gain? So here 17 is the probability, 17 divided by 67. Exactly. So this is the answer. What is the probability of a small gain under medium tuition, condition medium tuition? A small condition medium, or I would say this is given T2, S1 and T2. So what is the common value here? S1 is and T2 is 7. What about divided by 67? Oh, so yeah, sorry, correct. That is, what is the probability of T2 is 19, because that's correct. So this is a T2 value probability. Similarly, you can do all. What is the probability of S2 and just S2 and T2? Sorry, again, I'm using my mouse. So what is the probability of this S2 and T2? Exactly 11 divided by 67. Now, similarly, if I ask what is the probability of S2 or T2, S2 or T2, what will you do? this is union or you know, sign. Yes. Tell me the answer, or just numbers that you are exactly. Yes, that's correct. That's correct. 30. So let's see what is the S2. 33. 33 divided by 67 plus, what about T2? 19 divided by 67. What is the third factor? A and B means S2 and T2. S2, which is 11 divided by 67. Exactly. So this is, you know, you just divide this and you will get the decimal value. Yeah, you know, denominator must be there. So you subtract only after you divide with grand total in order to get. So now I think you are very much familiar with all this different kind of, you know, probability. So based on that, you know, marginal probabilities are like this. You know, what is the probability of S2? What is the probability of T2? What is the probability of 3? These are all called marginal probabilities. Okay. Joint probability, which is a common, which is called joint probability, and conditional probability I already explained. So, you know, in this, one of the, I think calculation is not correct in this, because maybe typing a mistake or something on this slide, but you don't need to get. So these are the different values: A, T1 and S1, T2 and S2, T3 and S3, S1, T2. You can frame all different kind of, you know, all different kind of probability based on that. Now we are coming on decision tree. That is very important part, you know, in real decision making in professional world. And how do we use here in this, based on contingency table, how do we draw a decision tree? Look into this again, a contingency table that has 44 total number, grand number, where 23 are stocks and 21 are bonds. So 21 are bonds and 23 are stocks. And, you know, they are in low, medium and high category. They have been divided based on that. So this is based on these things. So 11, 3, 7, 9, 3, 11. Okay. Now, based on that, you know, 21 is divided by, you know, 11 divided by 21, 7 divided by, and similarly. So you get these numbers. Bond fund here, this probability here, stock fund, this is a total is this. Now you can do this. So fund type here, look into this. So here you do the fund, and so bond fund, and you know how you get this, 21 divided by 44 and 23 divided by 44. So this, and then low expenses, medium, how do we get these? We are getting based on when we divide these numbers. This is, so basically these are low condition bond, medium condition bond, high condition bond, low condition, you know, similarly you can, the total has to be 100 or one of each, which is there. Now you are going to multiply this bond and this to get joint probability, which is B and L equal to probability of L condition B multiplied by probability of bond. So which is, you know, exactly same. Using conditional probability, we are going to get the joint probability, which is 25%. This is, you know, similarly 15%, and the sum is, now here you can see which one has highest probability, which has the lowest probability, where you will put your money. Let's say, so This is the highest. This is the highest. Stock and high expenses, bond and low expenses, they are equally 25% probability. The least is bond and high expense, which is 6.8%, or stock and low, this is also 6.8%. So these are the, so this is number one. This is also number one on your focus. This is 2, this is 3, and last, both are 4th. Is it making sense? So this is the decision tree. When you read a book, you will get to know a lot of examples. Now we are going on Bayes' theorem. This is another important theorem that has been given by Thomas Bayes, who was, it's like, 300 years ago, he gave us this, work, and provided a method called Bayes' theorem of revising probability to reflect new probability. What does it do? It gives a new probability to revise earlier probability. Means a new probability can be prior or marginal probability of an event B is revised after event has been considered to happen, or yielding posterior probability. So it has prior probability, it has conditional or posterior probability. The formula is very simple. B condition A that we have learned. So the upper part is probability of B and A. The probability of B and A would be, so probability of B and A has been, probability of B and A. So this has been revised with probability, and you can see simply probability of B. And I can write here probability of, so probability of A condition V equal. So this is the formula. Probability of A condition B is equal to probability of B and A divided by probability of B. Please remember, probability of A and B, A and B equal to probability of B and A, because it is a common part of both the things. So which is, if you write probability of A and B, you can get B and A. Where am I? Okay. So if I am just putting this here. So what I get here, probability of B or A and B, this I'm getting here. So the same, this part has been replaced with this, and that is what is Bayes' theorem. In some situation, PA is not given. Therefore, the most useful common form of Bayes' theorem is this. We are not going into the formula. Other thing, general form of Bayes' theorem, if you have multiple, categories, then the formula can be extended to the n level. And the example is right here, for example, we are not going into the formula and other things. Example, based on historical data, the percent of cases in 3 hospital trauma center and the probability of case resulting in a malpractice suit are follows: marginal, conditional probability, and this is, so Bayes' theorem, we can find probability of B1 condition A, and you can see all the numbers. So basically replacing, conditional probability formulas and just doing. So you can see this probability of A, how the probability of A has been shifted, and this can be replaced using the basic formula. And now based on that, the numbers can be inserted and we can get the numbers. So this is a simple example. Bayes formula means revised probability. And you can just look into the, the example. Now we are coming to the last option, which is called fundamental rule of counting. So how many cars can be registered using 3 alphabet and 3 numbers in Washington state? So for example, you have 3 numbers and 3, like, the car number is ABC, ABC 1, 2, 3. How many car can be registered? So 8, these numbers, letters can be 26. This can be 26. These can be 26. 0 to 1, 0 to 9 is 10, 10, and 10. Multiply all of them and you will get to know 6,760,000 car can be registered using 3 alphabet and 3 numbers. So this is, therefore, whenever we buy a computer, you can see number, labels are there, UPC codes are there. They are unique for each computer, each product. And how you can see that, how many, when you are manufacturing some product, how you can put a label, what should be the, how many numbers, how many letters can be there, based on that, you can make a decision. Factorial thing. What is the factorial? This is another simple thing, which is factorial 3 into factorial, what is the factorial value? Let's say factorial 5. So it is start with 5 multiplied with all previous values until 1. It does not multiply 0. If you multiply 0, everything will become 0. So 5 into 4 into 3 into 2 into 1. And that's what we are getting, 120, I believe. That is a factorial value. Similarly, factor 3 is 3 to 1. We don't multiply 0, otherwise everything will be 0. And that is, so everything up to that number to the 1 and multiplying, that is called factorial. Permutation and combination, that you have studied in your high school and before that. In an arrangement of a, arrangement in a particular order are randomly sample items. So let's say I have 3 items, and how many ways I can arrange those 3 items. I have 3 items, let's say 3 paper weights, and how many ways I can arrange. So this is the way. Simply these are available in calculator that you can do permutation. Combination, how many, like normally there are 20 members team which travel from one place to another place to play a Super Bowl. 20 members, how many people play at the end? Final 11 players. I think I don't know exactly about Super Bowl because I play cricket. In cricket, there are like 20 member team, they travel from one place to another, but finally when they play match, they play 11. How many ways, how many combination can be formed using 21 and selecting 11? That is called combination. So these are the numbers which are used for different other purpose. So this is a chapter number 5 in our book, and very easy thing. For example, let's say this is a real data of our, my pet database, which is Titanic. So everyone can understand. You can use your sales data. You can use your different, data. So how many are there? We have 2,478. I just select all. I just go under insert. I go under pivot table. I go here and I start with new option. So if you are looking, what option I'm going to select? Let's say I'm going to select male, or let's say I'm just, okay, you can't see the, now can you see this? So what I have done, I have selected the entire data set. I go under insert, I go under pivot table. Pivot table is right here. And under pivot table, I just use this, what I can say, I just use status. And here I put under status, or, and I have, or I can put a status, so I can get, these are the different status of the people. And then I can use from where they joined. And I can use and joined option right under values, and I can get, okay, these are the values. So DAC, I can get a cross tabulation. Belfast, 41, DAC people joined from Belfast. Engineer 221 joined. This 10 joined. Officer 8 joined. Passenger, look into the Southampton, 41, 29, and some of them were not there even. So this is a cross tabulation, and you can see 2,478 numbers right at the end. And now you understand the contingency table, you understand the different probability. It's very simple to run a probability. Similarly, you can take any data, any values, any numbers for your own, real empirical data, and you can do the Excel, this, contingency, and you can come out with your own probability numbers about any event or any conditional event. So this is what I am expecting you to do in fill in the blanks of second part in the fill in the blanks, where you have this. Can you do what you can do, Steve? Yeah, this is, no, we can't do in Minitab. Therefore, we are not having the Minitab for this week. We can't, this option is not available in Minitab. However, this option is available with advanced add-on option in Excel that costs like 10 or 20 bucks extra, but I don't want you to go and pay extra to buy additional thing. However, you can do mini pivot table is everywhere in every Excel. So you can simply do this pivot table, and then you can do manual, you can just crunch the number. So this is what I wanted to cover. And if you have any question, I'm here. Otherwise, I would like to say have a good night. And despite all the bad comments, bad, opinion people given, I will continue for only 5% or 10% of people. I will try my best to, have this. Thank you so much. Bye-bye. Good night. Bye-bye.
Bye. Thank you.
Bye.
Bye.
Bye.